All right, so a lot of my instruments have vacuum fluorescent displays. And I recently replaced this one, which was going bad. And some of these, like this one has some burn-in in it. It isn't uniform. This one seems to maybe have some burn-in also. I'm not sure if that's... Yeah, I think this has got a little bit of burn-in also. But what I want to talk about today is how do these things work? So yeah, let's go take a look. So this is the old display that I recently replaced, and so let's see if we can't light it up and make it do something. Let me turn the power supply on, and I think we'll see. Yeah, if you notice the second digit, the middle segment right there is glowing, right? We'll get a closer look there. All right. So let me draw a picture of how these things work, and then we'll get out the microscope and show you the insides of these things. So if you remember old TVs with CRTs or cathode ray tubes or oscilloscopes with cathode ray tubes, how do they work? They had a display in the front, right? They had a kind of a tube that kind of came and necked down over here, and everybody knows there's like super high voltage here, and what you did was you created an electron, okay? You created an electron, and then you had some magnets and stuff, and you accelerated the electron towards the CRT, and the CRT was coated with phosphor. So when the electron hit the phosphor, it was absorbed. The energy was absorbed and then re-emitted as a photon, and so you had something like a Lissajous figure or something on your oscilloscope, and that was for different reasons. But it's the electron being accelerated and hitting a phosphor that's the key, right? So that's the way these vacuum fluorescents work. We're going to have a wire that's our heater, and then we're going to have a grid. Okay, a grid. And the heater is going to heat up the wire so that we're boiling electrons off, right? So these electrons are being created on the surface of this wire, and these free electrons want to go somewhere. And if we put a positive voltage on the grid, they're going to go, oh, look at that, and they're going to go zip down this way, and they'll go towards the grid, all right? So while a CRT requires very high voltages because the distances are very large. This is a very short distance, and so only plus 18 volts is enough to get the electrons to move in this particular case. So that's what I'm using here, 18 volts. And then how much voltage do we need? The heater, well, you really just kind of need current, and you really should be driving these with an AC voltage to make it uniform and stuff, but you can drive them with a DC voltage, they'll work. So right now I've got the heater wire at 3 volts. Okay, so 3 volts is the heater and 18 volts is the grid, all right? And so they go down. So how do you make something glow? Okay, the electrons are moving, but where's the phosphor, right? Well, if you have a surface here and you coat it with phosphor, okay, so this is our phosphor. If the surface here is also 18 volts, they'll just zip all the way down. They'll see this one, but then those keep going because there's momentum in the electron, and so they will hit the phosphor and glow. All right. So when you look in this thing, you're actually looking in this direction. You have to look past these heater wires and look past this grid, and then you'll finally see the phosphor glowing, okay? This will make more sense when we look under the microscope. But remember that there's wires that are being heated that create the electrons, and then they're being accelerated down with something that's on the grid, and then individual pieces of phosphor can glow, and they can be different things, right? And each one of these can have a wire to it, right? So if this is plus 18 and this is 0 volts and this is 0 volts, only that one will light up, okay? If you have another one over here and you also run plus 18 to it, then both of these will glow. Okay, hope that makes sense. All right, let's look under the microscope. I think this will be more interesting under the microscope. All right, so here we are under the microscope. Here is a digit. All right, so it has it's upside down, but it's okay. It has different segments and different digits. And I think you can see on the over each digit is a screen. Okay, there's a grid. So that is a piece of metal with really fine grid on it, and that's held at 18 volts if you want that particular segment to light up, that digit to light up. And then the individual segments are also wired out, and you have to put 18 volts on them if you want a particular segment lit up. So you can see there's a little frame around each digit, a little wire frame around each digit, and they go down to these contacts, this silver epoxy to make contact to those wires. So that's the grid, all right, and then those areas there are the segments, and then painted on them are these phosphors. So the kind of the lighter color there is phosphor, and the rest of it is just a conductive surface. If we move over to the side here, you see those little gold posts there, and there's like little fine wires going off to the left. Those are the heating elements. Okay, those are the filaments that I have 3 volts going on. Okay, and so there's not many of those. There's a couple of those, maybe half a dozen across the display. Those little fine little wires there. And then if we go over here to the second digit, and I turn the power supply on, and you can see that one is kind of glowing there. Let me turn this off. It'll make it self-evident there. So there's without the microscope light on, you can see that that particular segment is glowing. And if I light up its neighbor as well, I can turn on both grids. If I turn on 2 grids, you can see that the one next to it is also glowing. All right, and then the segments, I could create another segment as well, right? All right, so I hope that helps. Let's see if I can. Yeah. You can put any shape, though. It's just paint, right? You're just painting phosphor. So it's really nice to make really odd shapes and displays and stuff. These things are actually quite easy to manufacture because it's just artwork, really. It's really quite easy. So anyway, thought that's interesting, and yeah, hope you learned something and enjoyed it. All right, I know everybody's going to ask, so I'm going to have to answer the question. What about, is that segment actually dead? Well, there it is. That's the, let me see if I can get that particular segment to light. Yeah, there we go. I'll get it under the camera here. So that is the segment that was supposedly dead on this display. So at least under these drive conditions, that particular segment is working just fine. Now, I don't have all the segments on. I'm not driving it under the same conditions and everything, but that particular segment is still working in the display. So Will my voltmeter continue to work in the future? I don't know. Or was there some other problem with this that shows up when you actually drive the entire display? I don't know. But I'll find out.